Now let's take the time to set up the Red Hat Enterprise software using FTP as a repository. The same web server that we've been using, the SUSE Enterprise 10 box, also functions or doubles as an FTP server. It's running an instance of VSFTPD, or Very Secure FTPD daemon. So let's open a shell, connect to that system, create an appropriate user, and then commence the installation using FTP as opposed to HTTP. So we'll SSH as root to 192.168.75.100, and we'll use the user add command to create the user as opposed to YAST, the full-fledged interface. Now we don't want this user to have the right or ability to gain a shell or gain shell access to the system, so that's why we're using user add. And then we'll specify the location of the shell using the dash lowercase s option, followed by, instead of bin dash or bin KSH for corn shell or C shell, we'll indicate bin false to indicate that the user cannot log in to a full shell session, but will be permitted to log in using FTP. We'll then also indicate that the user's home directory is the root directory where we can find the Red Hat files, which is serve www.linuxcbt.com, beneath which we'll find RH5 and i386. The user's name will be Linux install, and then we'll assign a password to the user Linux install. We'll set it to simply ABC123, and then we'll confirm our ability to connect to the share by FTPing as Linux install to 192.168.75.100. Once we've authenticated, we'll see that we're in serve www.linuxcbt.com, and we can navigate into RH5, i386, just like we can using the HTTP protocol. And beneath server, we'll find all of the RPM files. So this looks the way it should. With that said, our FTP is set up. So we've created a user using user add, and we've ensured that the user has only shell access to, or no shell access, that is, to the system. Let's just launch an instance of gedit. We'll open our nodes, and towards the bottom, label this section FTP installation. So, steps include 1. Create FTP user account on FTP server. And we did so using user add, bin false for the shell, and a home directory of serve www.linuxcbt.com, followed by the username Linux install. We then set a password, Linux install, and we confirmed. So step 2 is to confirm FTP connectivity as the user Linux install. So we've done all that, it works. The next step is for us to reboot the server and specify FTP as a method of installation. We'll be using the boot.iso image CD as well, and we'll simply type Linux ask method. So step 3, reboot server with boot.iso CD and type Linux ask method at the prompt. So that's what we're going to do now, but we've set up FTP access, so we're sure that it will work. So now we're rebooting our system, and we'll be prompted by the installer menu momentarily. Again, we're going to type or enter Linux space ask method, which will then propel us into an installation which will prompt us for the source of the installation binary RPMs, which we've set up as FTP. And it's still available using HTTP. We haven't changed the location of the RPM file. Simply, we've simply created a user who has FTP access and has a home directory of the web root. So we'll go ahead and type Linux ask method. And we'll indicate FTP. We'll tab to accept the defaults for IP version 4 and 6, then specify the IP address of the server. Now, the way you indicate the path to the Red Hat Enterprise Linux server directory differs slightly from HTTP. We'll need to indicate the full path from the top of the directory, or from the root of the file system, as the VSFTPD configuration permits access to anywhere in the tree. So we'll indicate serve www.linuxcbt.com rh5 i386. This is the full path. We'll also spacebar on use non-anonymous FTP. The default FTP installation uses anonymous access to connect to the FTP server, but our FTP server doesn't support anonymous access. So as a consequence, we need to indicate the username and password that we created earlier. And that user is Linux install with a password of abc123. This will attempt to connect to the FTP server. And once you see the stage 2 file being retrieved, then you know it's working as expected. And there it is. It's looking pretty good. X configuration. And now we're up in graphical mode. The default installation uses graphical mode, unless you indicate text from the command line or from the main menu, using either the boot ISO created CD-ROM or the DVD or first CD of 5 in the Red Hat Enterprise set. So we should be prompted or presented with the GUI in a moment. Again, this is not a Kickstart installation. This is simply an FTP-based installation, which will provide us with a full GUI interface, allowing us to indicate how we'd like to proceed with package selection, time zone settings, partitioning, run level, bootloader, and various options. So we should be up momentarily as this gets detected. And there's the opening screen. So we'll navigate down to Next. We'll skip the installation number. This will search the hard drive for existing installations of the RH5 software, and will indicate that it's a new installation as opposed to an upgrade, which would work for perhaps version 4, 3, and even for version 5 if you'd like to just simply reinstall the software. So let's go ahead and click on Next. There are hard drives. We can remove all partitions or create a custom layout. Remember, advanced storage is for iSCSI connectivity. And there's a current layout from our most recent installation, which includes a RAID device. So all this can be wiped if we'd like to clean things up. There's devmd0, which is contingent upon the software RAID partitions that are currently available. Let's click on delete to get rid of this partition as soon as our interface changes here. And there we've got software RAID on the first hard drive, SDA, the first SCSI hard drive. Then let's scroll down and remove the partitions from the other drives. We'll leave the swap on SDB. It's always a good idea to keep swap on a separate disk, a disk independent of your primary disk. So now we've got free space on SDC, as well as SDB and SDA. SDA, however, has one partition which will assign to boot. We can just edit this partition and indicate that the mount point will be /boot, as opposed to recreating the partition. So let's go ahead and just leave it intact, leave it unchanged, preserve the data on it, or we can format it, either or. For a clean installation, you should format the partition, so we'll format it as ext3. Then we'll also create a root partition that's large enough to hold all of the other partitions. So let's create a large root partition on the SDA disk. We'll make it 20 gigabytes, and then leave the remainder of the space for LVM and subsequent RAID configurations. So again, the only difference with this installation is that the source files are being fed by the FTP or supplied by the FTP server as opposed to the HTTP server. We haven't changed the location of the software. Keep that in mind. So this will be set to 20 gigabytes, and if you want it to be a primary partition, then indicate as such. Now we've got SDA 1 and 2 and a swap that's on SDB. Let's just scroll down to be sure that the partition is swap space and not just a partition that can be used for any file system. It needs to be explicitly defined as swap, and there you can see it's type swap. So with that said, let's move forward. And it's been selected, destroying all data. Just a note that the partition will be wiped. We want a bootloader password for security, and Red Hat Enterprise will load from dev SDA2 as opposed to dev SDA1 or SDB or some other partition. Let's indicate a password here. Then click on OK to confirm the changes. Then next to move forward. Again, this installation will allow us to interact fully, selecting packages, configuring DNS and IP information. Totally the opposite of Kickstart, which prompts for everything, or does not prompt for everything. This installation prompts for everything. So let's go ahead and set the host name. serve2.linuxcbt internal. Now we'll move forward. DHCP works just well for IPv4 and v6 configuration. Time zone's correct, however the clock does not use UTC. Let's set root's password. And then move forward. We can customize the installation now if we'd like, if we wanted to install additional packages such as Kickstart and others that aren't selected by default, or just leave the defaults to customize later, so once the OS is up and running, we can make a determination then as to what additional packages, if any, we need. Dependencies have to be resolved, and once all the dependencies have been taken care of, we will be propelled into the next phase of installation where the file systems are formatted and the copy of the files begin. The dependencies are almost finished, and we're almost ready to jump to the next stage. Again, the files aren't being pulled locally. We're not using the DVD to boot and install the system. The files are being pulled across the wire. Later on when we're up, we'll confirm that the installer indeed connected using FTP by perusing the VSFTPD logs. That'll tell the story regarding time of connectivity and the files that were accessed. So we're making pretty good progress here. This is moving forward exactly how we want it to, all based on the FTP protocol. And now we're ready to move forward. And the files will be copied using the FTP protocol. The file systems were quickly formatted. And we'll simply let this elapse towards the end rather than waiting for all the files to copy. And our installation is complete, so we'll proceed with the reboot process. And we're booting up again. And once again we'll enter single user mode just to be sure that the system's up and running with the appropriate partitions before moving on. So to recap, we've performed an FTP installation of Red Hat Enterprise Linux without shifting the installation source tree by providing access via user account and password. And the user account Linux install has no shell access via the bin false interface. So that's another neat little trick provided by the Linux shell environment. And again, we have our interface. We can modify the bootloader by pressing P to insert the password. And then once we've specified the password, we'll be able to edit the VM Linux kernel startup line by pressing E and navigating to the second option. Remember, the first option indicates the location of the root file system, the hard drive and partition on which it exists. And the last line is the initial RAM disk, which provides a space for loading drivers necessary for gaining access to the storage subsystem. So we'll E to edit and then append single to boot into single user mode, confirm the layout of the file system, and then we'll be off to the races. At this stage we'll press B to boot. And we're booting up. UDEV will come up momentarily to detect any devices connected to the system. System clock set. We're now in single user mode. DF-H reveals the file systems, including SDA1, which is the boot file system, 100 megabytes, and SDA2, which is about 20 gigabytes, and is the root file system. Swap on. -S reveals the swap file set to about a gigabyte, and a grep of default from etc init tab will reveal that the run level default is 5, so if we boot the system, we'll boot to an X Windows environment. So again, last recap, we've installed the system using FTP. Let's go ahead and reboot and move on.